So the last type of reaction we are left with is the addition reaction. So it's again a simple reaction. As you all know, addition means you are adding something to a compound. And you know that the addition reaction occur only if there is an extra bond. So, or you can say that addition reaction is a property of the unsaturated compound, because they are only the compounds which contain the extra bond. As we know that the alkenes contain one extra bond, one pi bond, and alkynes there are two pi bonds, right. So, what happens in it actually? So, it is a reaction in which the products get formed by addition of some reagent, and obviously it has to occur in the unsaturated organic compound, that is the alkenes or alkynes, because they are the compounds which have the extra bond. So, just look at the example. Here I have the alkene, that is the ethene. I am going to add HCl, right. So, what happens? This and we always keep in mind we have to restore the valency of carbon as 4. So, this H will attach to this carbon and Cl will attach to this carbon. There is no definite rule that this hydrogen is going to attach to this one only and this Cl is going to attach to this. This is not any rule in this case of symmetrical alkene. So, it becomes CH3, CH2, Cl, that is we have ethyl chloride, or you can say the chloroethane. Now, again as we divided the substitution depending upon the type of this thing, the which group is replacing the other group, we classified as electrophilic, nucleophilic and free radical. Likewise, if we are adding this thing, if the reaction is actually initiated, will be the correct word. If it is initiated by addition of electrolyte, that means the first atom which or a group of atom which attach is an electrophile, then it is called as electrophilic addition. And if the first group that gets attached to the organic compound is nucleophile, then it is nucleophilic addition. And if it is initiated by the addition of free radical, then it is the free radical the addition reaction. So, just look at the example. Suppose I have the CH2 plus CH2, I am going to add HBr to it. So, what happened here? This will just result in shuffling of electrons first. So, what will happen? This is my electrophile, this is my bromide ion. So, that means first this will get attached, let us say, to this place. So, what happens? It becomes CH3 and it is CH2, a carbocation, and so in the first step it will be formed plus Br negative, and then this Br will attach to this compound forming CH3, CH2, Br, right. And if there is an unsymmetrical alkene, we have already discussed in the alkenes when we were doing in hydrocarbons, that if we are adding this kind of compound into an unsymmetrical alkene, we use the Markovnich's rule, which obeys that the negative part attaches to that carbon across the double bond which carries the lesser number of hydrogen ion. And we also studied there that this rule actually gets reversed when the peroxide is present, like benzoyl peroxide is present, that is the anti-Markovnich's rule is followed in that case. So, here we will not be discussing those rules actually, because we will be doing in the hydrocarbons. So, as far as we are concerned to this topic, you should know that there can be an addition of like if it is initiated by the addition of H positive, it is strictly an electrophilic addition, and what we do, this H gets attached resulting in the formation of carbocation, then this nucleophile addition is followed, but it is called as an electrophilic addition because it is initiated by first by an addition of electrophile. Next we have is the nucleophilic addition. So, what happened? I have this compound, that is the acetaldehyde. I am going to add a cyanide radical to it. So, what do I get? I get this thing. Bond between C and O gets single, because we know that the addition occur only when there is an extra bond, and this bond will be formed here, it will make cyanide attach, and as a result O will get the negative charge. Now, what we do in the second case, we add H positive, because Cn was not alone, it was actually HCl. So, what happened now? It forms CH3, CCN, H same, and O gets attached to OH. So, this is something called as acetaldehyde cyanohydrin, acetaldehyde cyanohydrin. Now, if it is initiated by the addition of free radical, so obviously it is called as the free radical addition reaction. So, just see here what happens here. Suppose this is my Br, right. So, what happens, or I will take an example, a proper example I will show you within this thing reaction. Let us see, it is HBr. So, it undergoes heterolytic homolytic fission and forming the result of formation in the result of free radicals. So, now I have this compound CH3 CH double bond CH2. So what happened, it is going to be initiated by the free radical. So let's say we initiated with Br dot. So what happened, it will gain an electron, they will just equally share the electrons. So what will happen, it will be something like that, and this will be a free radical. Now this will react with the another free radical, that is the H, and result in the formation of CH3, CH2, CH2Br. That is the this thing, propyl bromide or bromo propane. So this is what is the addition reaction. So we have discussed almost all the reactions, the general reactions, and apart from that you may encounter a kind of isomerization reaction. So isomerization is also kind of rearrangement, because here what they do, the cis form is changing into the trans form, or you can say that if it is 2-propanol, 2-butanol, it is becoming the 3-butanol. So this is how you can encounter actually this thing, the isomerization reaction, and they are actually nothing but the subtype of the rearrangement reactions, right? Though the conditions are different, but still they are the isomerization ones. So these are all the reactions which we have discussed. They are the common reactions which occur in case of the organic compounds, and you need to remember these reactions, and all. Obviously you should be able to do a certain kind of reaction or predict the type of the reaction. You should know that. And this thing, if you talk about their types, so it's very simple, because you just have to consider an electrophile, nucleophile and the free radical, and you already know that what actually they are, right? You know that in the previous lecture we did that what are electrophiles, that is with the positive charge, the neutral compounds, you know everything. So before starting this, you should be well versed with the type of the attacking reagent, because once you will be familiar with that, then it will be a you can say a quick task for you to learn this thing. So this is what is the organic reactions.